Almost in all the chapters they reduced something. Few topics they reduced. In your first chapter, look at that. In for chapter 1, are you hear my voice and PCV is okay? Video is okay? It is visible? PCV is visible, audio is okay? Any problem in that? Yes, audio and video. I hope that audio and video are okay. Right. In chapter 1, so the first, that composition of functions and inverse of function both are eliminated. So that is exercise 1.3. That exercise 1.3 that exercise 1.3 totally deleted. Okay. And your exercise 1.4, that is binary operation, that is also already deleted. Okay. This is in chapter 1. What is in chapter 2? In chapter 2, so nothing eliminated in exercise, only some simple concepts eliminated. In chapter 2, the graph of the function. Okay. So the graph of inverse trigonometry function, that only eliminated, and some elementary properties. Elementary properties only deleted. Okay, elementary properties means simple properties. But there are many properties given. Only the simple properties, elementary properties only deleted, and graph of inverse trigonometry function also deleted. But mostly they never ask question in graph of the inverse trigonometry functions. They never ask the question in graph, but that portion is deleted. Okay. In chapter 3, okay. So one simple definition means, what is the definition? In real numbers, your xy equal to 0 implies or, look at that, either in real numbers, either x is equal to 0 or y is equal to 0, then what is my xy? It is automatically 0. Either x is 0 or y is 0. What is my xy? It is 0 in real numbers. But in matrices, look at that, in matrices, A not equal to 0, B not equal to 0, that means non-zero matrices, but my AB equal to 0. This concept omitted. Only one definition related to definition. We'll discuss some. We discussed only one example problem. This definition deleted. This topic, this section, that particular definition, and based on this problem, problems based on this definition, it is deleted. Okay, and another one, the elementary operations. Okay, section 3.7, 3.8, section 3.7, 3.8, and exercise is 3.4. So exercise 3.4, totally deleted. Exercise 3.4 totally deleted. Okay, elementary row operation, column operation, based on that finding inverse, everything deleted. Okay, chapter 4. So here in chapter 4, that exercise 4.2, properties of determinants and problems based on properties of determinants, that is totally eliminated, deleted. Okay, so in chapter 4, exercise 4.2, properties of determinants and problems based on properties of determinants, that is totally eliminated, deleted. Okay, and one more definition, one concept is there. That means check the equation is consistent or not. Consistency. Checking consistency. This is also eliminated. Checking consistency means the given equation, system of equation is consistent or not, or equation solution exists or not. Exist means unique solution or infinite number of solutions. Okay, so that only that simple concept eliminated, but all other concepts are there. Minus, cofactors, finding determinants, adjoint of A, inverse of A, solving system of equation, everything will be there. So some of the students are thinking that the solving system of equation is not there. Solving system of equation using matrix method is there, but this consistency, checking consistency, finding number of solutions alone eliminated, deleted. Okay, right. Now come to that chapter number 5. In chapter 5, exercise 5.8. That exercise 5.8 is totally deleted. All other checksums are there. All other exercise compulsory there. Only exercise 5.8. Okay, chapter 6. Exercise 6.1. Exercise 6.1 deleted. Total exercise. That section, that exercise totally deleted. And approximation. Exercise 6.4. These two are deleted. Okay. So in this exercise, they never ask in board exam. In this exercise, they never ask anything in the board exam also. But here they may be asked some 1 mark or 2 marks. 1 mark or 2 marks. But that is also deleted. Exercise 6.1. That is rate of change of quantities, rate of change of bodies. Okay. Right. So chapter 2 we will discuss tomorrow, because I have only today I have only volume 1. Volume 2 we will discuss tomorrow. All these first 6 chapters are volume 1. Volume 2 we will discuss tomorrow. Okay. Okay. Right. Now come to that the problem number 22nd. Discuss the continuity of cosine, cosecant, secant, cotangent, and everything. Discuss the continuity of trigonometric functions, all trigonometric functions. Okay. So first of all, take it as sin x. What is my sin x? My f of x is equal to sin x. Okay. Find the limit of this function. Limit extends to any point. I'm going to check that the function is continuous or not, or at any point. Limit extends to c. My f of x is, actually what is my f of x? My f of x is nothing but sin x. So therefore this is sin x. Now apply x is c. So therefore I will get only c. So when you take my left hand limit, this is my f of x. When I'm taking my right hand limit, this is my f of x. Okay, so that's why I no need to find out the left hand limit, right hand limit separately. I'm just finding the limit. This is the value. But what about my value of the function? F of c is also sin c. Same. Both are equal. Both are equal means my function is continuous at all the points. C is any point. Limit extends to c, f of x is equal to f of c. So therefore, my f is continuous at all the points. Okay, f is continuous since f is nothing but sin x. Okay, you see the graph. The graph of the function. Okay, see the graph of the function itself, it is continuous. My sin x is always continuous. Without any breaking, I am drawing that curve. Okay, right. So now come to that cosecant x. What is the cosecant x curve? What is my cosecant x? Here it is 0, here it is pi, here it is 2 pi, here it is 1. So therefore my cosecant x is coming like that. Here my cosecant x is coming like that. This is the diagram for this cosecant x. Okay, this is for minus pi here. This function is continuous or not. I'm just drawing the cosecant x. This function is continuous or not. Your sin x is continuous. Cosecant x is continuous or not. Any idea? This cosecant x is continuous. It is a continuous function or not a continuous function? It is a continuous function. Why? Sir, at 0, the function is not continuous. Sir, at pi, it is not continuous. Sir, at minus pi, it is not continuous. Sir, similarly, at 2 pi, it is not continuous. Sir, look at the graph, sir. So, but you have to concentrate the domain of cosecant x. That 0 belongs to your domain of the cosecant x. That pi belongs to the domain of the cosecant x. Minus pi belongs to the domain of the cosecant x. 2 pi belongs to the domain of the cosecant x. So the point is not in your domain. No need to check for the continuity and discontinuity. It is a meaningless. Okay. So therefore, so the domain of this cosecant x is, cosecant x domain is, okay. What is the domain of this cosecant x? R minus. We have to eliminate some values of x. My x is equal to n pi. Why, sir? My cosecant x is nothing but 1 by sin x, reciprocal of the function. When x is equal to n pi, what happened? This is x not equal to n pi. When x is equal to n pi, that means x is equal to 1 pi or 2 pi or 0 or 2 or 3 pi or minus pi. Your sin x is 0. Please try to understand. Your sin x is 0 when x is equal to n pi. When sin x is 0, 1 by 0, cosecant x is undefined. My cosecant x undefined for these values. The function is undefined means you eliminate these values from your domain. So therefore, these values x is equal to 0, 1 pi, 2 pi, 3 pi, minus pi, these values not in your domain, you don't bother about that. You have to check the continuity. You have to check the continuity at the domain values only. If any point is not in your domain, don't bother about that, leave that. At the domain points, the function is continuous. Yeah, it is continuous. The domain is 0 to pi is there. It is continuous. At 0 to pi, it is continuous. Only up to pi, not equal to pi. Less than pi. Okay, pi to 2 pi, it is continuous. 0 to minus pi, it is continuous. Minus pi to minus 2 pi, it is continuous. So therefore, these points not in your domain. So therefore, you just exclude these points. You just exclude these points. Okay, so therefore, the function is continuous. So therefore, here f of x is continuous. F is continuous. That is sin x is continuous. Here cosecant x is continuous. So, okay, so therefore my cosecant x is continuous at all the points. My f of x is equal to cosecant x. This is continuous at all the points in the domain of f. Okay, so similarly we can prove it. Cos function, cos x is continuous, secant x is continuous, tan x is continuous, cot x is continuous. All are continuous functions. All the trigonometry functions are continuous functions only. Okay. Right. Now come to that next problem. Find 23rd problem. Find all points of discontinuity of f. Find all points of discontinuity of f, where f of x is given like that. My f of x is sin x by x. Here x plus 1, x less than 0. Here x greater than or equal to 0. This function is continuous or not? That means find the discontinuity point. Find the discontinuity of the function. So now look at that. I'm going to check that continuity at x is equal to 0. Then come to that left hand limit. What is my left hand limit? 0 minus f of x. Okay, limit x tends to 0 minus. What is my f of x? My f of x is sin x by x. Okay. So now apply 0 here. What is the answer? Sin 0 by 0. What is sin 0? It is 0. So 0 by 0 means it is an undetermined form. This is undetermined form or indeterminate form. Undetermined form. Okay, 0 by 0 means you never conclude anything. So this is 0, 1, we never conclude. This is infinity, we never conclude. This is 1, we never conclude. We can cancel it 0 and 0. It will be taken as 1, sir, no. So that is also not a correct one. Mathematically, it is not correct. So therefore, we never conclude anything for this 0 by 0. It is infinity, no. It is also not concluded. So that 0 by 0 means undetermined. So infinity not exist as a, that is also not concluded. So then what to do, sir? We have to think differently. We have to go for some different approach. What is that, sir? For left hand limit, you can take it as my x is equal to 0 minus h. That means this is my x is equal to 0. My left hand limit means my x is approaching from this side to this 0. Suppose that means I am taking x value is here and here and here and here and goes to nearly 0. Okay, so therefore I am taking it as my x value is not exactly 0. My h is very small value. Okay, 0, my x is 0 minus of some small value. That means my x is lies between here. Okay, so therefore when you take x is equal to 0 minus h, when x is tends to 0, what is my h tends to 0? My h is also tends to 0. When x is 0, what is your h? Where h is also 0. Okay, now apply all these things in your left hand limit. 0 minus f of x. Limit. What is my x tends to 0? My h is tends to 0. Okay, what is my f of x actually? Sin of x by x. Actually, what is x? Sine of 0 minus h divided by x. What is actually x? 0 minus h. Don't cancel these two, it is not possible. Okay, so therefore limit h tends to 0. What is sine of 0 minus h is sine of minus h. My sine of minus x is minus sine x. So therefore minus sine h, 0 minus h. Your minus minus cancel, I will get sine h by h. What is the value of limit h tends to 0 sine h by h? What is the value of limit h tends to 0 sine h by h? What is the value? Limit h tends to 0 sine h by h. So therefore, I'm getting limit h tends to 0 sine h by h minus cancel. We have a formula for that. Limit h tends to 0 sine x by x is nothing but 1. You have studied in 11th standard. So therefore, the answer is 1. That is my limit x tends to 0 minus f of x. Lower limit, left hand limit is 1. Come to the right hand limit. So the right hand limit also you apply the same procedure, because once you apply the left hand limit, you have to follow the right hand limit also. Okay, what is my x? My x is x plus 1. See the problem? My x, f of x is x plus 1. I'm going for the right hand limit. Okay, so here also you can take it as, for the left hand limit, you can take it as x. My x is 0 minus h. For the right hand limit, you can take it as x is equal to 0 plus h. Okay, so my h, when x tends to 0, my h is also tends to 0. Please try to understand why I am taking 0 plus h, why I am taking 0 minus h. So when you take that left hand side limit, my x value is lies between that, lies in the below 0 value. My x value is taken from these values. These values is nothing but below 0 values. Below 0 value means it is represented as 0 minus some h. H is very small one. Okay, your h is, your x is not cross that, not beyond that with 0. Okay, your x is closely goes to 0 only. Okay, so therefore for left hand limit, take it as x is equal to 0 minus h, and when x tends to 0, you will get h tends to 0. For right hand limit, you can take it as x is equal to 0 plus h. When x tends to 0, my h tends to 0, apply here. So therefore my h tends to 0, and here apply 0 plus h. My x is 0 plus h plus 1. So now apply h is 0 here. What is the answer? Again, I will get 1. H is 0, 0 plus 0 plus 1, that is 1. So my left hand limit, my right hand limit, both are same. Come to the value of the function. What is the value of the function at x is equal to 0? Value of the function means you just substitute x is equal to 0 here. So therefore my value of the function is also 1. So everything is same. Limit x tends to 0 minus f of x. Limit x tends to 0 plus f of x. And the value of the function. All are same, which implies f is continuous at x is equal to 0. All are equal means f is continuous at x is equal to 0. That is, we have already discussed, that is a known one. Okay, but what is the question? Find all points of discontinuity. But here I have proved that it is continuous at x is equal to 0. What about the other points? At x is equal to 1, what is the function? The function is continuous or not? At x is equal to 2, the function is continuous or not? At x is equal to minus 2, the function is continuous or not? What about the other points? Are you completed? Shall we move to the next slide? Okay, so now come to that. My other points. So look at this one. Suppose x is less than 0, not equal to 0. Then what is that? This is separately continuous. Sin x is continuous. Now only we have discussed. This is a polynomial function. This is also continuous. Okay. So we have already discussed my f and g, two functions are continuous at a point. Then my f plus g is continuous. F minus g is continuous. F into g is continuous. F by g is also continuous. All are continuous. If these two functions are continuous, addition of two continuous function is continuous, subtraction of two continuous function is continuous, product of two continuous function is continuous, division of two continuous function is continuous. Here, sin x is continuous since sin x and x. This is sin x trigonometry function. This is polynomial function. Sin x and x continuous. Okay, sin x by x is also continuous. This is also continuous separately. That means in the interval minus infinity to 0. In the interval minus infinity to 0 only, up to 0 only, not equal to 0, less than 0 only. Okay. Similarly, this function is also continuous. My x plus 1 is also continuous because this is a polynomial function. Any polynomial function is continuous, we have already discussed. So therefore, for greater than 0, that means 0 to infinity, my polynomial function is also continuous. Okay. So therefore, also x plus 1. So this is continuous, also continuous in the interval. What is the interval? Minus infinity to 0. Also x plus 1 is a polynomial function. Okay, so which is also continuous. In the interval 0 to infinity. So now look at that, the function is continuous at minus infinity to 0, 0 to infinity, and here look at that. This is the conclusion, f is continuous at x is equal to 0 also. So therefore, my f is continuous, okay, at all the points in the domain or real number. In real number R, my f is continuous at all the points in real number R. Okay. So then, but what is the question? Look at the question. Find all points of discontinuity. Points of discontinuity. How to find out the points of discontinuity? What is the meaning of points of discontinuity? A function is not continuous at any particular point, and the function is said to be discontinuous. But here the function is continuity at all the points. So therefore, there is no point of discontinuity. No point of discontinuity. Okay, the function is continuous at every point. No point of discontinuity available. Okay. Please take that. We'll move to the next slide. Next problem. Are you finished? Come to the next problem. Determine if f is defined by 24. My f of x is given like that. X square sine 1 by x. This is 0. X not equal to 0. Here x is equal to 0. Okay, this is continuous or not? This is a question. Limit x tends to 0, f of x tends to 0 minus f of x. So here the lower limit and left hand limit and right hand limit both are same. Why? Here the left hand limit, right hand limit both are same. Why? Because when x is less than 0, my f of x is this is. When my x is greater than 0, this is my f of x. Okay, so for both the cases, I having the same f of x. That means you have to find out only one limit. If you are going to find out separate limit, means no problem, you'll get the same answer. Same answer will repeat. Okay. So therefore, this is equal to limit x tends to 0. My x square is, this is my x square sine of 1 by x. Apply 0 here, 0 into sine of 1 by 0. What is sine of 1 by 0? That is infinity. What is sine of infinity? My x is always lies between minus 1 to plus 1. You know the curve of the sine function? This is a sine function. Look at the range of the function. Where my range of the function is, value of the function is lies between minus 1 to plus 1 only. If you take any other infinity value, very large value, okay, so you will get that the value between minus 1 to plus 1 only. But into 0 means what is the answer? It is 0 only. That is into 0. That is the left hand limit, right hand limit. Both are equal to the limit of the function. The limit of the function is nothing but 0. Why? So when you apply 0 here, 0 into sine 1 by 0, this is sine infinity, 1 by infinity. Sine 1 by infinity, your sine x value always lies between minus 1 to plus 1 only. So therefore, sine of infinity is also lies between minus 1 to plus 1. So that value into 0, it is always 0. Now come to the value of the function. What is my value of the function? My f of x is equal to 0 means what is the value of the function? It is 0 only. So therefore, these two are equal. So this is the limit x tends to 0, my f of x and f of 0. The limit of the function and the value of the function both are equal. So therefore, my f of x is continuous at x is equal to 0. Okay, what about the remaining points? Sorry, x is equal to 0. Okay, sir. What about the remaining points? X less than 0, x greater than 0. The function is continuous or not, sir? When x less than 0, this is my function. This is separately, your x square is separately polynomial function continuous. The sine of 1 by x is a trigonometric function that is also continuous because sine x is continuous. Okay, product of two continuous function is also continuous in the limit. This product of two continuous function is also continuous in this less than limit, less than 0. Similarly, greater than 0 also, this product of two functions is continuous function is continuous. Okay. Are you okay? F of x is continuous at x is equal to 0. The next slide. My x square, f of x is equal to x square into sine of 1 by x is also continuous at x is equal to c. My c belongs to this interval, any interval. Okay, so c belongs to minus infinity comma 0 union 0 comma infinity. Because this is continuous, product of two continuous function is also continuous at any point. Okay, except 0. Why? Because for 0, I have a different f of x. At x is equal to 0, I am getting another f of x, different f of x. But here you can take any point c in this interval. Okay, your left hand limit, right hand limit, both you have your f of x is same, x square sine 1 by x. Okay, so therefore the function is continuous at all the points. So therefore f of x is continuous at all the points, are simply continuous. Okay. Look at the next problem, 27th problem. So look at the question, find k if f of x is equal to kx square 3 k less than or equal to 2, k greater than 2 at x is equal to 2. Find k if f of x is equal to kx square x less than or equal to 2 and 3x greater than 2 at x is equal to 2. So here f of x is continuous at x is equal to 2. So you look at the previous problem. In previous problem, we are discussing about that continuity. F of x is continuous or discontinuous. At which point it is continuous, at which point it is discontinuous. We are discussing that. But here, in this problem, f of x is continuous at some particular point x is equal to 2 is given. We have to find out the value of k. Right? What is the continuity definition? Continuity at a fixed point. Continuity at a point. What is the definition? Limit x tends to 0 minus f of x. What is my limit x tends to 0 minus f of x? Left hand limit 0 minus what is my f of x? K into x square. Okay. I'm sorry, it is not 0, it is 2. Because the point is 2 is given. Okay. Since the point 2 is given, take it as the point is 2. X tends to 2 minus, x tends to 2 minus f of x. This is kx square. Apply x is equal to 2 here. What is the answer? Limit x tends to apply 2 here when my x is 2. Apply here 2 square 4k. So any problem in our audio and video? Students, please. Audio and video both are okay. You please send a message, any one of the students, please respond. Any problem in our audio or video? Yeah, good. Thank you. Thank you, Bob. Look at that. Now, what is the left hand limit? Limit x tends to 2 minus f of x. My f of x is kx square. Apply that x is equal to 2. I am getting 4k. Come to the right hand limit. What is the right hand limit? What is the right hand limit here? Limit x tends to 2 plus f of x is equal to limit x tends to 2 plus what is my f of x when x right applying the right hand limit, my f of x is 3. Again I will get when I apply x is equal to 2, again I will get the same function 3. But these two are equal. Why? Since f of x is continuous. F of x is continuous at x is equal to 2. What we are getting? The left hand limit the right hand limit, both are equal. What is my left hand limit? 4k. What is my left hand limit? 3. What is the k? 3 by 4. What is the question? Find k. So therefore this is the answer. Are you okay? Are you clear? Come to the next problem. Problem number 28. Question number 28. Question number 28. That is also find k. Find k if f of x is f of x is equal to kx plus 1 and cos x. My x is less than or equal to pi. Here my x is greater than pi. Is continuous at x is equal to pi. Are you okay? Look at the question. Find k if my f of x is equal to kx plus 1 when x less than or equal to pi, cos x when x greater than pi is continuous at x is equal to pi. Continuous means what is the definition? Left hand limit, right hand limit, and value of the function also. But it is continuous given means you can take it as left hand limit and right hand limit, both are equal. What is my left hand limit at x tends to pi? My left hand limit is limit x tends to pi minus, okay, my f of x, this is my f of x, kx plus 1. Okay, so therefore what is the answer here? Suppose applying pi here, apply pi here, that is k pi plus 1. This is my left hand limit. Come to the right hand limit. My f of x is limit x tends to pi plus, my f of x is cos x. Actually, what is apply pi here, cos pi. What is my cos pi? My cos pi is minus 1. These two are equal. Why? The function is continuous. Since f of x is continuous, it is given continuous at x is equal to pi. My left hand limit, right hand limit, both are equal. What is that? X tends to pi minus f of x. Limit x tends to pi plus f of x. That is, what is my left hand limit? My left hand limit is k pi plus 1. What is my right hand limit? That is minus 1. So therefore, which implies my k is equal to, this plus 1 becomes here minus 1. So therefore, minus 2 by pi. Are you okay? Come to the 29th and 30th. 29 and 30. What about 29th problem? F of x is equal to find k. The question is find k if my f of x is kx plus 1, this is 3x minus 5. When x less than or equal to 5, this is x greater than 5, is continuous at x is equal to 5. Okay, find k. Yeah, please try and tell me the answer for this k. 29th one. What is the answer? What is the answer for this? Limit x tends to 5 minus left hand limit. Limit x tends to 5 minus. My f of x is kx plus 1. Apply 5, x is 5 here. That means finding the limit. That means apply 5 here. That is 5k plus 1. Okay, what about here? My right hand limit. Limit x tends to 5 plus. My f of x is 3x minus 5. Find the limit value. How to find out the limit value? Just substitute 5 here. That is 15 minus 5. That is 10. 15 minus 10. And these two are equal. Why? Since my f of x is continuous, it is given, it is continuous at x is equal to 5 is given. Since my f of x is continuous at x is equal to 5, my left hand limit, right hand limit both are equal at x is equal to 5 because it is continuous. Okay, what about the left hand limit? My left hand limit is 5x plus 1. Okay, my right hand limit is 10. So therefore solve this. This is 5k. 5k plus 1. This is 5k plus 1 equal to 10. My 5k is equal to 10 minus 1, 9. K is equal to 9 by 5. Okay, my k is equal to 9 by 5. Come to the next problem. Problem number 30. Find the value of find a and b if my f of x is equal to 5 x less than ax plus b, 2 less than x less than 10. 21x greater than or equal to 10 is a continuous function. Okay, look at that in previous problem. Here it is continuous at x is equal to 5 given, sir. Here also, here it is continuous at x is equal to 5. Here, x is equal to 5 given, sir. But here it is nothing is given, sir. At x is equal to 2, it is not given. X is equal to 10, it is not given, sir. It is continuous function means this is continuous at all points. Please try to understand. This is continuous functions means continuous at all points of the domain. Continuous at the all points. That means at x is equal to 2, it is continuous. At x is equal to 10, it is continuous. So therefore, I am going to find out the left hand limit and right hand limit at x tends to 2. X tends to 2 minus what is my f of x? I am finding the left hand limit. Okay, my f of x is 5 only. So therefore, this is 5. Then apply x is 2. My f of x is 5 only. There is no x. I will get the function value 5. That is a constant function. Come to the right hand limit. Limit x tends to 2 plus my right hand limit is this is my ax plus b. Apply x is 2 here, that is 2a plus b. These two are equal. Why? Since f is continuous at all the points. Okay, these two are equal. What is that equal? 2a plus 5, 2a plus b equal to 5. This is equation number 1. What is the question? We have to find two constants. In previous problem, we have only one constant k, but here we have two constants, a and b. So at this point also continuous. I am going to the next point, limit. Going to find out second point, left limit f of x is equal to limit x tends to 10 minus. Apply f of x here. That means x. That means ax plus b. Apply 10. That is 10a plus b. Okay. This is one equation. Come to the right hand limit. X tends to 10 plus f of x. Limit x tends to 10 plus what is my f of x? My f of x is 21. What is the value? When you apply x is 10, again you'll get the value 21. These two are equal. Why? My f is continuous at all points. So therefore, these two are equal. 10a plus b equal to 21. Now solve these two equations. You will get it as a and b. Okay, solve these two. How to solve these two? When you subtract 1 minus 2, your b cancelled. Okay, 2a minus 10a, that is minus 8a. And the right hand side is, this is 5 minus 21. Okay, what is 5 minus 21? Minus 16. So therefore my a is equal to 2. When a is equal to 2, what is your b? Apply here in this equation. When a is equal to 2 means this is 4. Okay, 5 minus 4, therefore b becomes 1. My a is equal to 2, b is equal to 1. Are you okay? Yes. So almost we have completed the first exercise, continuity exercise. Tomorrow onwards we will discuss about that differentiation. Okay, we'll start the differentiation. Don't miss the class, tomorrow class. We'll discuss the differentiation in our tomorrow class. Okay. Okay, this is our first slide. This is so second. Okay, homework. So you please try to complete that exercise 5.1 remaining problems. Okay, tomorrow onwards we are going to concentrate that second 5.2 exercise derivative. You please try to complete that the remaining problems in a exercise. Okay, thank you all, thank you so much. Thank you all, thank you so much.